In section 5.8, we'll be talking about modeling using variation. The definition of direct variation is the following. If x and y are related by an equation of the form y equals kx to the n power, then we say that the relationship is direct variation and that y varies directly with or is proportional to the nth power of x. In direct variation relationships, there is a non-zero constant ratio k, which is equal to y divided by x to the power of n, where k is called the constant of variation, which helps us define the relationship between the variables. So for example number 1, we want to be able to solve a direct variation problem. And how do we go about that? Well, given a description of a direct variation problem, solve for an unknown. First, we need to identify the input x and the output y. 2, we're going to determine the constant of variation. You may need to divide y by the specified power of x to determine the constant of variation. Number 3, you're going to use the constant of variation to write an equation for the relationship. And number 4, you're going to substitute known values into the equation to find the unknown. So for example 1, they're telling us that the quantity y varies directly with the cube of x. So this is really important to decide what formula that we're going to be using, because you'll see more than just this one. So when it says y varies directly with the cube of x, well, that tells you that you're going to use this form. Okay, now if y is equal to 25 and x is equal to 2, then we want to find y when x is 6. So before we do that, we need to use the general formula for the direct variation with a cube. And so defining what this first sentence says, it says y varies directly with the cube of x, and then we have that constant. We need to make sure that k is also part of the general formula. The constant can be found by dividing y by the cube of x. So the first step is to write out the formula to solve for k. Well, we're going to divide both sides by x cubed, so now k is going to equal y over x cubed. And then we're going to substitute the value of 2 in for x. And we get 25 over 2 cubed, which is equal to 25 over 8. So now what we've done is we found the k constant, and so we're going to use that constant to write an equation that represents this relationship. So now this k is now going to be represented as that constant into that general formula. So now we have y, which is equal to 25 over 8 x cubed. And then we're going to substitute x equals 6 and solve for y, because now it's telling us to find y when x is equal to 6. So we're going to plug in 6 in for x. And so we have 25 over 8 times 6 cubed, which gives us 675. Now the graph of this equation is a simple cubic as shown in figure 2. This is what the graph would look like. So here at the value of 6, the output y value is going to be 675.